a few examples, that kind of stuff. Other than that, yeah, I think.
You have like 30 seconds.
Yeah.
Or you can just.
I mean, yeah. This is just ad-libbing, yeah. Other than that, yeah, I think we don't have many major assignments. I think the next assignment's due on like Tuesday, right? So, once you're done with the exam, you're done for another few days, right? How's chat?
Did you put the slides on the website?
Yes.
Okay.
There's a bunch of people on these slides right now. Is that 12 people or 72 people? I think that's 12. All right. So before we get started, does anyone have any questions to start us off with? Anything anyone wants us to cover? Yeah? Comparators, iterators, that's not on this list. Whoops. I deleted the slides that were from last semester on those. Whoops. We can talk about it a bit. Yeah. Yeah. Huh? Well, we have to write boxes and pointers on the midterm. I cannot answer that question. Yeah. I can't really answer, like, are you able to do, are you going to be expected to do X, Y, Z on the midterm? Because that's going to spoil some information about the midterm, and, like, I am aware of what is on the midterm. Yeah. Sorry about that. Any other questions before we get started? Yeah.
Could you summarize the imports like comparators or iterators?
Can we summarize the imports that we have available?
Like the ones we went over that we might do the test, like comparators and iterators.
I mean, I can think about that. There are a number of imports. I think largely if you have it on the reference card, then that's something that you can use, yeah. There was another question back there too, right? Can a class be both a comparable and an iterable? And an iterable? Yeah, both can. A single class can implement multiple interfaces. All you need to do is to just make sure that every single like function in either of these interfaces is somewhere in that class. Yeah. Any other questions before we get started?
There's lots of requests on Zoom for iterators and comparators. And
All right.
Wing it.
Yeah, we'll wing it.
Okay.
All right.
You can go through your slides first.
So, yeah, I went over the stuff that y'all wanted covered. I picked, I think, these main things that it seemed a lot of people were asking about. And I made a few slides for each of these. Let's go over these. So the first thing is that static dynamic typing and typecasting stuff. I think it's useful to see exactly what goes on when you write a Java program. So when we press the play button on a Java program, there's two steps that happen, actually. It's not just a single step, it's two separate steps. The first step is compilation, and that's kind of where the computer gets to see if your code makes sense. So this checks for things like syntax errors, like did you miss a semicolon? It puts together a list of like all the methods and attributes of every class. So this actually includes all this inheritance stuff. So the way I like to think about it is that if you define a class, let's say animal, and you have some functions there, and then you have the class dog, then dog is going to inherit everything from animal. It's going to copy all the animal code into its own body, except for the stuff that gets overridden. So that kind of makes it so that everything the animal can do, a dog can do as well. So it kind of copies over all this code. Now, if the class implements an interface, then it'll inherit all the default methods, and it'll also check to make sure that any of the non-default methods in the interface have been properly overridden by the child class. That way, you know that this interface is actually implementing everything that you need to. Now, in order to override something, you need to have the same argument and the same name as the other class. So this collectively we call the function signature. And if these mismatch, then you end up getting a completely separate method. The most common instance where this happens is things like equals. If you have everything eventually like inherits from object, and within object you have this equals object O method, right? You have this public bool equals object. But if you have a dog, then you might want to just write public bool equals dog, right? But if you do this, then these two are two completely different functions, and neither one's going to override the other. So it's not going to properly override the equals method. This is something that's outside of the scope for this semester's version of DMS, so you don't need to worry about us doing this, but you might do this accidentally in your code. So what you need to do is you need to actually say that this is an object, and then within your code, like check if, what was the format?
Pardon?
What's the,
If
d
instance of
instance of dog,
give it a name like other dog.
O, D. Yeah, something like this. The syntax is weird. But yeah. So if you want to set an equality thing, you need to override with object, not with the class that you're trying to override with. So equality needs to be checking against any possible object. Yeah?
Ooh, true.
Yes? Look, I grew up with C#, okay?
It's also lowercase.
Is it lowercase? Okay. Any other syntax typos?
I think it's good now.
Something like this. Yeah. All right. So in addition to this, it'll go through your code, and it'll assign a static type to every variable. So every variable or every like partial computation within your code, it gets assigned a static type according to what type the compiler thinks it is based on just that line of code. So normally this is kind of what the type of the variable was declared. So if you declare a variable as type list, then the static type is list for that variable, or as the type of the return value. So if you evaluate some function, then whatever the return value's type is, that's going to be the static type of that subpart of a line. The only exception is if you do a typecast. So when you do typecast, you do, for example, animal new dog. What this does is it creates a new dog, a dog object, and then it typecasts the thing to an animal. So now the static type of this piece of code is an animal. So this also does check to see that this is possible, or theoretically possible. So if I do animal new dog, this is fine because all dogs are animals. It is theoretically possible for this typecast to work. If you do dog new animal, this isn't going to work, but it's not going to work in runtime. During compile time, it'll say, yes, an animal could theoretically be a dog, so I'm going to say that this is fine for during static runtime. Only when we actually run the code later do we realize that this is broken. If you do something like list new animal or list new dog, then Java's going to complain at you because it is very, very, very clear that dogs are not lists. At least I hope so. Dogs are not lists, right? Yes. So generally speaking, if you have this type of typecast, then it's going to break because dogs are definitely not lists. There's no parent-child relationship between them. So it's just going to break there. Yeah?
When do we know when it's going to be a compile time error versus a runtime error?
When do you know if it's compile time versus runtime? It is going to be a compile time error if it is guaranteed impossible just from looking at the types. So here, a dog is definitely not a list. And there's no universe in which a dog could potentially be a list.
How do you define that it's definitely dog?
Dogs are not lists. Dogs can definitely not be lists. But some animals are dogs, right? It is possible for an animal to be a dog. So this is going to be allowed. If you do dog new animal, right, you can theoretically have an animal that is a dog. It doesn't know that you're defining as a new animal, and therefore the actual type is animal, which is not a dog. It just knows that it is an animal. So you could theoretically say, yeah, this is possible. It's possible that this animal is a dog. So the static type check is going to pass. It's only in the dynamic actual run do we see that it's an animal, not a dog, and therefore we crash. Yeah. This also means that you could technically do like new cat, and you can like typecast this to an animal. Add some parentheses here. And like this is going to pass a compile time check because a cat is an animal, so that's going to be fine. And an animal could be a dog, so that's fine as well. So you could do this kind of double casting. You could actually, if you really want to, you could do like object list like this. And you're basically lying to the compiler that, yeah, trust me, this cat, it's actually a list. But no, in order to fool you, I'm going to say, no, it's actually an object first. And this object that's completely different from this previous thing I talked about, it's definitely a list. Trust me. Yeah. Yes?
When would casting a parent to a child work?
When will casting a parent to its child work? It only works if it actually is that child. So for example here, right, if I say animal here, and then I say cat again here, right? Then I can see that it's going to work even in the dynamic time. So it'll typecast the cat to be an animal. That's fine. It'll typecast the animal to a cat. That's theoretically possible, so the compiler will work for there. When we actually run this code, the cat is going to become a cat, which is going to become a cat. So a cat is a cat, and it's fine. Yeah. So after that, it's going to check each line in isolation to see if that line is possible to run. So it'll look through each function. It'll look for the static type of each variable. And it'll check to make sure that that particular line has a way to run. So as an example here, right, if I have a list type, list L, let's say that I define the L somehow. And then I want to do some list-specific thing. L dot, name me a list operation. Get. Name me a number. 3. All right, L dot get 3. So what does this do? Well, it checks to see if L, it's a list. 3 is an integer. So it checks to see if the list class has some function that takes in an integer and is a get, is named get. And it finds that, and it'll use that function. Or it'll look at that function and see that that exists. It's going to decide on that function signature. It's not actually going to run the code because we're still in compile time. Now, if I do something different, like, I don't know, list.get 3.5, then this will do something weird. It'll look at 3.5, and it'll see this as a double. Double being like some decimal value. And it'll look to see if there's a function that in list that has get, has the name get, and which takes in as input a double. It doesn't find that, so it's going to run a compiler error saying that it doesn't know what you mean by get 3.5. Which kind of makes sense. You can't really get the 3.5 element of a list. Yeah. The same thing happens if you do, I don't know, name a word that is not a list operation. Eat. L dot eat 3. Lists don't know how to eat, so it won't understand what to do with this. And this is true even with you do something like resize. Like even if your array list has a way to do a resize operation, it's not going to be able to do this because L is a list. Because L is a list, it doesn't know what type of list it is, so it's only going to assume that it can do list-specific things. It's not going to be able to do things like resize because a resize is an array list-specific thing, and it doesn't know that this is an array list. So because of that, it's going to not allow this line. Yeah?
Can we define L to be an unparameterized list, like you have here?
Can we define L to be an unparameterized list? No, I'm just ignoring this. It really should be integer or something like this. Yeah, you have to do something like this if you want to like actually have this. But yeah, yes? Yeah. So yeah, if you decide to do this, then you can do this by casting this to an array list first. And if you do this, then it'll work. So the L list is going to be treated as an array list. That is a theoretically possible typecast, so the compile time check is going to pass there. And then it'll check if array list has a resize operation. And if you made your resize operation public, then you would be able to do this directly. Yeah? Can you cast in the line above? Like this? You can, except that doesn't do anything. Because the array list is already definitely an array list. Yeah. The problem here is that L is defined as a list, not as an array list. So if you wanted to do this, you would have to like define this as array list like this. Otherwise, you would need the cast. Because each line of code only looks at that one line. Yeah. Yes? It changes the static type to array list for that one line only. Yeah, this typecast only affects a single instance where it's being written. Like if I don't know, did L here, like there was some operation that like had some list, then this second L is also going to be of list type, not of array list static type. So this typecast only affects this one time that L is being looked at. Yeah, yes? Huh? Yes, this thing is going to have static type array list. That's all the compiler sees. When we actually run this in dynamic time, we'll actually turn this into an actual array list. So it'll have dynamic type array list as well. There was a question up here, right? If you do this, is it going to compile? I do not believe it will. I think the compiler is smart enough to say, hey, you didn't define this variable before you tried to use it. But I'm not sure. I would have to check. Yeah.
So this is a little like different question and topic, but I just wanted to know about like when like void functions or like functions that return like nothing sometimes, but also could return something. What are the rules on that, like in general?
Uh,
If you return like null or something on a function that has a return back.
so functions that return void, but could also return something, those do not exist in Java.
So you can't return null and have a return.
Void is not null. Null is specifically something that exists in all types, which refers to something that doesn't exist. That is different from void, which is where you're returning, when you're not returning anything at all. So there's a difference between returning something that is definitely not exist yet, and returning something or returning nothing at all. Yeah. Yes.
So I have two questions. So if you had the assignment slide where you had a list of its or L equal to new array list. So if you had on the left side of the assignment, you had a cast, you casted list of integers to array list,
No, this is just going to be a syntax error because you can't typecast the type you're defining something as. Yeah.
And also, if we know, like say we were talking about that L doesn't have a size method. Say if like some other parent of list had, they hypothetically had the method defined. So like, would that work then?
Yes, if list or a parent of list had a resize method, then that would work. Yeah, but because list doesn't have a resize method itself, you would need to do the typecast to say that, yes, this is specifically an array list, and array list can do something that normal lists can't do. Yeah. So as it turns out, we'll discuss this more when we get to 61C. But once it does this, it'll actually try to rewrite your code in a way that's more computer friendly. It turns it into what we call an assembly language. And that is an easier programming language for your computer to understand. Now, normally this translation thing only happens once over the course of like any time that you run your code. The main difference between how you work on IntelliJ is that every time you press the play button, it recompiles because you're likely changing your code and making like changes. Once you actually like publish your code, it's compiled once and that's it. It doesn't get compiled more often than that. So these checks only happen at this like early stage during this compilation. Now, when you run your code, it'll actually run the program and it'll rely on whatever the dynamic type of the object. So when you actually run the code, you can see what type of an object it actually is. And it can check to see if any like typecast or anything is broken. If it calls a function, then it will use the method of the same name in the dynamic types class. So even if you typecast something to be a list, if that something is actually an array list, then it will do the array list specific behavior, not the list behavior. Now, if it has multiple methods of the same name, like a method is overloaded, then it'll pick the one whose signature matches. So if you have two methods here, like I think a max function and a max comparator, then it'll look to see which one best matches the code that you wrote. If you write, let's say, integer I equals a.max, like this, then it'll see that, yes, like a.max takes in 0 arguments, so it'll pick the max with no arguments in it. If you see max comparator, then it'll be like this, something like this. Like if you have this, then it'll see that the closest match is the comparator version. Yeah. Now, it's actually kind of complicated what happens if you have multiple inputs or if you have inputs that are not like the direct subtypes. We kind of say that it's too complicated. We're not going to cover it here. We're not going to test that kind of thing. Yeah. It also finds any illegal actions that can't be found by the static type analysis. So if you remember here, like we said, like this. Like this line would have worked through static type code, but it's not going to pass the dynamic type check because it'll see that a cat is not a list, and therefore it is going to complain, hey, you lied to me when you said that this cat was a list, when this object was a list. And if you lie to the compiler, then the runtime is going to crash the program for you. Yeah. It does not like to be lied to. It will not do what you like if you lie to the code. Other than that, any other errors that can't be caught during compile time, like if you're accessing an array out of bounds error, if you run out of memory, all those things get caught during runtime. And these are what we consider to be the runtime errors. Now, we do consider that the hardest part of DMS is out of scope for this semester. So we won't override any overloaded methods. We won't have ambiguous overloads. Some of the things I say on this slide do only apply given these simplifications. Like when I say that you use the method of the same name in the dynamic types class, that's not always true. Sometimes if you have an overridden, overloaded method, you end up getting this weird thing where it uses a different method than what you'd expect. But you don't need to worry about that. It's way too complicated. It frankly does not help you beyond Java. And you shouldn't be writing code that ends up doing that anyway. Yes?
Okay, I just have a question on like adding the line. Like, let's say you had like a cat that's completely unrelated to anything.
Mhm.
An object attached to a completely other unrelated class, right? But then you use a method on that like thing that you lied to passing on multiple times that exists on both cat and thing that you were trying to overload and it didn't. Would it still get mad at you for lying to you, or will they actually run it?
So let's say that list I don't know. What's something that both a cat and a list does? Size. All right. All right. So this is still going to complain to you. It's the typecast itself that actually does the complaining. So it doesn't even check the size method, yeah, or the size attribute. Yeah. Yes.
But just to reiterate, even if you have like an empty or line that just says this object cat and you don't apply any function on it, that line itself would still error.
Yes, this line will error, unless cat is an extension of list somehow.
People on Zoom want you to repeat the question before you answer.
Yes, yes. So that question was kind of like, what happens if we have like some function size that's both a cat and a list operation? Is this still going to work? No, it's not going to work. Yeah. Yes, was that a question back there? Huh? If you're writing your own, if you're writing your own class and you want it to be cast into like an array, or if you want to write some code, if you want to write something that can be cast into a list, what do you do? Is that what you're? How do you turn a cat into a list? Sorry, I cannot. Huh? The body parts. Why are you turning your cat into a list of body parts? Please do not turn your cat into a list of body parts. You would probably need a function to do this, like within cat public list parts. And then you would do like mu cat cat.parts. Like this is going to be allowed, I guess, but do not do this. Yeah. Oh no. Anyway. Anyone have any questions on this? What time is it right now? 1:38. Do you all want to go over an example, or do you want to continue to the next topic? Who wants to continue? Who wants next topic? Or sorry, that's the same thing. Who wants next topic? Who wants example? Seems like next topic is what I saw more. All right. So here's kind of, I think the next topic that a lot of people were asking for were like lists. So here's kind of the different types of lists that we have. The main types we have are linked lists and array lists. So for linked lists, we have a few options. So the first option was that kind of like original list version that we had, the int list. We called this a naked linked list because the type itself is deliberately recursive. It contained a value and then a pointer to the next element. it isn't actually used in practice too much because like it's not nice to use. If it only has a value and a next, it doesn't have a lot of nice features we have. For example, if you want to calculate the size, then you need to go through everything all at the same time. It takes forever to do that. Instead, we make our singly linked list. We turn our naked linked list into like an internal node class, and then we add a bit more functionality on top of that to be like list-specific things. So in a way, we're saying that a list isn't a value with its next. We're saying that a list is something that contains as many items as we want, a list of actual things. And then it's actually implemented by using a bunch of nodes which just point to the next item. It only lets you move forward in the list. So this is less useful than a doubly linked list. But it does use less memory, so it does have some niche use. We also add a sentinel. That's kind of just like some dummy node that doesn't do anything. It's just there to make sure we don't have to handle like an empty list edge case. The doubly linked list is the same thing as a singly linked list. The only difference is that we have a pointer to the previous element as well. So that way we can go forwards or backwards in our list. We still have a sentinel. We still have pointers. It still has like a node class that does this. Other than that, like, it's largely the same as a singly linked list. Yes? Should we assume that it's always circular? Singly linked lists and doubly linked lists, the ones that we show, generally it will be circular. If it doesn't specify, then you can ask. Yeah. So general rule of thumb is not to assume something unless it's written down. But this is close enough that like you can request a clarification. And if it is meant to be circular and we didn't say it, then we will have to write down that, yes, it was circular. Yeah. The other main type is the array list. The array list is ultimately based on what we call an array. That's kind of the default Java's version of a list. It's natively supported by Java, so it's not actually considered a class. The main difference here is that you need to specify how long the list or the array is before you actually start using it. And you can't change that length once you decide it. So if you make an array of length 100, it is stuck at 100. You cannot make it larger at any point. Because it can't grow indefinitely, it's actually not considered a list. A list, by definition, needs to be able to grow as much as possible. Meanwhile, the array list is kind of like the list type that uses that array in the back end. The main difference is that you need to do that resize operation every now and then to instead of, so that like when you run out of space in your length 100 array, you can increase to 200 array instead. Now, if you set this up properly, if you like multiplicatively increase the size, then on average, you get a constant time access per operation. We'll discuss this more in detail in a few days. But effectively, for an array list, you can imagine that it takes a constant time to look for a particular item. It takes a constant time to add a particular item. Meanwhile, for a linked list, it'll take constant time to add items to the start and end. It'll take linear time to look for a particular item. Like if you have 1 million items in a linked list, then you have to go like 500,000 times to get to the middle. And that takes forever. All right. Any questions here? All right. I'm actually going to go over these slides first. We'll see if we have time for examples after this.
I was going to ask, people want to, there were so many requests for comparators. Do you want to try winging that instead of lists?
Yeah. Well, that's why I'm also doing comparators, iterators at the end, yeah. So the other major thing that I think some students were asking were like public versus private. I think largely this boils down to like the fundamental like philosophy of Java. In Java, the main thing that you do, the main philosophy is that you try to restrict yourself as much as possible in what you allow yourself to do. So kind of the reasoning behind this is that the more things you let yourself do, the more complicated your code becomes. If you have a dog class that can do 500 things, then you now have to think about all those 500 things that you could possibly do with a dog. Instead, what I'm going to do is I'm going to restrict you to like 5 or 6 things that you're allowed to do. and everything else you don't get to touch. So the example that we have, that doesn't involve like public versus private is actually this interface idea, right? The list interface tells you everything that lists can do, but you still need a class to make the list, right? You might think, well, why did I make this list interface in the first place if I needed to make an array list class anyway, right? It seems like it's a lot of extra work for no gain. The main reason why we do this is because, generally speaking, we only use the list operations on array lists. We don't use array list specific stuff. So instead of writing array list integer a equals new array list, we write list integer array a equals new array list. That way we restrict ourselves from using only the list specific behaviors in A. We can't use like resize because resize is an array list specific behavior. Why is that better? Well, if I decide that, hey, I don't want to use an array list this time, I want to use a linked list instead, I can just change the single line here to be a linked list. And that guarantees that the rest of my code works properly, because all the rest of my code only knows that A is a list. It doesn't know that it's an array list specifically. As long as you're not doing any typecasting and things like that, you can safely change your code from using array list to using linked list with only one line of code difference. So this actually helps make your code a lot more flexible, easier to change in the future. We highly recommend that you just restrict yourself as much as possible. So if something is defined as an array list, but you can define it as a list instead, define it as a list instead, it'll make your code easier to change in the future. Any questions? Yeah. If you set it as an array list, a static type, later you could treat it as a list, but that's riskier, right? The fact that we're defining it right here, right now, as a list also tells me through this line that I'm only ever planning on using A as a list, not as an array list specific. Yeah. Part of writing code is communicating. So when you communicate, you want to make things as clear as possible. And even if you're writing code that only you will ever read, you are going to be communicating with yourself 5 days from now. And 5 days from now, you're not going to remember anything you remember right now. So if you try to lie to your other people when you write your code, then you are lying to yourself in 5 days, and you're going to hate that you lied to yourself 5 days ago. Don't lie to yourself. It's not good. So public and private actually fall into this idea. With a public method or attribute, every single outside class that you see can change or see that variable. So that means that things like add first, add last on list, those are things that everyone outside the list class can see. Everyone outside the list class can use those. Once you build the class and you build some stuff that uses that class, you can no longer change these public methods without risking an entirely broken code. It's like a load-bearing wall, right? Like if you build a wall and you make it load-bearing and then you attach like another floor on top of it and you try to like remake this wall and destroy it, your entire house collapses. So you can't change your public methods as easily as others. Private methods are kind of like something that you do yourself internally. It's not anything that the outside classes can see. And because of that, you can basically change it however you want. It's like a non-load-bearing wall. You can destroy it. You can play around with it. You can just remake it into some other form. It doesn't matter. You can just safely change this as much as you want. As long as your code within your class works fine with it. Now, there are actually two other levels that we don't cover in this class. We have protected and packaged private. Packaged private is kind of like what happens if you don't write protected or public or private or anything. The main differences here is that protected actually allows subclasses to see your variable, and then packaged private allows classes within the same folder to see it. Yes?
If you have a nested class and the class inside is private, can you still access the private variables methods of the nested class wrapping?
Yes, the question was talking about nested classes versus inner classes. I have a slide for that. So with nested classes, inner classes and outer classes can always see each other's things. It bypasses the standard rules of access modifiers. It still ends up affecting things outside. So if you have an inner class, you generally want to make it private, because otherwise, if you make it public, then some outside code could theoretically create a new object of a list, right? And then make a node. Like if you define like public array lists, or sorry, linked list T, and then you have like inside it public node, right? If you have a node class inside, then I could theoretically write some code linked list integer equals new linked list. Let's call this A. And then I can say A dot node node equals new A dot node, like this. Right? I could theoretically write this code, which doesn't really make sense and kind of bypasses the public-private modifiers. So because of that, we generally try to make inner classes private. If we make this private, then we can no longer run this line. This line is not going to work because a.node doesn't know that node exists. The ideal code that you write is going to restrict the classes as much as possible. If you can make a method or attribute private, make it private, because that'll make your code more flexible in the future. All right. Are there any other questions on public versus private modifiers? Yes.
Like, so of a nested class is good, then you can only access it by like doing outer class dot subclass or dot the nested class, or could we directly do like a node,
If an inner class is public, then you will need to do this, because this is actually associated with a particular instance, right? This is not a static class as well. So it'll be associated with the variable A. If this was static, like this, then it's associated with linked list, and we'd actually have to do linked list.node to access it this way. In either case, we need to use this dot notation to get access to the inner class. Yeah. Yes? Can you make the constructor of the inner class private? I'm not sure. I think even if you do that, you might still have access to the default constructor, which all objects have, which just takes in no input and which returns a blank object with no variable set. Yeah. You cannot use a particular instance for a static method, no. So effectively, the word static here, what it means is that it is associated with the general concept of linked lists, not a particular linked list. So in this case here, right, each node is actually dependent on what particular linked list you're working with, because an integer linked list is going to have a different node class than a floating point linked list or a dog linked list. Yeah. So you can't access static from like instance or instance from static. Yeah. Yeah, you. Yes, if you are within a inner class and you write some private variables, right? So if you do private class node, and then like private int t value, you can still access t from within the linked list class. So inner classes and outer classes, they bypass the standard access restrictions. As a result, there's absolutely no reason why, if you have a private inner class, you should ever use public here. Because basically, it is never going to be accessible anyway outside. So might as well just call it private. Yes? The node object we create is an instance of the a.node class, actually. It's not an instance of the linked list.node class or an instance of the node class itself, because each individual linked list creates a new node class for itself. Yeah. Yes.
So if a class that has a parameter for a generic has static methods, when we access those methods, we don't need to parameterize it.
If a class with a parameter has a static method, then what actually happens is that you're not allowed to access the particular generic type at all. The generic type just doesn't work properly because it doesn't necessarily know what type T it is.
So we need to instantiate them to access.
Yeah, T is defined per linked list to be integer or a string or whatever. So by default, there's no static static T thing that will actually work. This will immediately error because you don't know what T is within a.
Well, T then
Yeah, you could theoretically have a static linked list K copy.
but when you try to access that from the class, what would you call the class? Without the parameter?
So if you write this out, then what it does is it defines the K in terms of this linked list K here. Yeah.
Wait, so how would you call that method? From outside, like in the
From outside, you would call linked list dot, I think.
so you don't need to have the
Yeah. The bracket thing is only to specify a particular like class type. Yeah. All right. I'm going to move on to like comparators.
Wait, sorry, really quickly. I think your static linked list copy doesn't work because you can't have K if it's static.
Huh?
You can't have a placeholder K if it's static.
You can't use the static. You can't use the one from the T, but I'm here defining K as separate.
Got it,
Yeah.
got it, yeah.
K is an
You're
entirely
separate.
different one,
You're
so
good.
because of that, it works.
Yep, you're right.
Yeah. Yeah. You can't use the T directly, but you can use K as a separate thing. Yeah. So comparators and iterators. I think that's the topic that y'all want to cover. So I think overall, the main thing is that we have two different things to compare stuff and two different things to iterate. So we have two interfaces. We have the comparable interface and the comparator. Now the comparable interface kind of acts as a way to compare your class to other things of type T. So we have the compare_to method that allows you to compare two things. So for example, you might say that a dog implements comparable dog, and this will allow your dog to compare itself to other dogs. You can even do something weird like comparing dogs to cats. This will allow you to compare a dog to a cat and only to a cat, not to another dog. So you can do this kind of weird thing. If you really want to, you can do a compare to all objects. Kind of weird. You don't really, I don't know how you compare a dog to a list. Meanwhile, the comparator function, it acts as a way to, it's kind of a machine that compares two items of the same type. So it'll compare T and T together. So generally speaking, the comparator T class is its own separate class. So dog comparing machine implements comparator T. And using this, you're able to compare two dogs and determine which one's bigger. In any case, all of these comparators follow the same pattern. -1 means that the left side is smaller, right? I think. 0 means that it's equal, and then 1 means that the right side is smaller. I think. Perrin, do you remember this?
Huh?
Is this right? I forget which one's -1 and +1.
-1 is if the first item is smaller than the second item.
Okay, so this is right, yes. Yeah. So this is kind of how comparables work. For iterators, we have iterator and iterable. Now, iterable just means that there is a way to make an iterator out of this. The iterator itself is kind of like a generator function from Python. It kind of just does something, but it yields items over and over. So it has the has-next, and it has the next operations. Next just gives you this next item in the iterator. Has-next checks if there's a next item. And you can use iterators by themselves as generating functions. Like you can make a public class square generator, iterator integer. And then you can do like int I equals 0, public int next, return I plus equals 1, return I times I, something like this. And if you do this, then it'll act kind of as a generator of all the square numbers. So you can do this kind of thing. With iterables, you need to create an iterator for it. And generally, it's designed to just iterate through all the items in that list. All right, any questions on this? Or the comparator? All right. If not, yeah, it's 2. Yeah.
For example, what if you made a list that could take in like a dog class or something like that? So wouldn't that kind of achieve the same result if you iterated through that list? Like if you